Welcome to Know It All, a place to connect with researchers to answer all questions on health, science, technology, business, culture, and more. This episode on What is a Space Telescope was created for you by Kaylee. In this topic, Know It All will answer: what is Space Telescope? Describes Hubble Space Telescope, Spitzer Space Telescope, Herschel Space Observatory, Chandra XRay Observatory, James Webb Space Telescope. Space telescopes are a type of telescope that are designed to be used in outer space. They differ from ground-based telescopes in a number of ways, the most significant being that they do not have to contend with Earth's atmosphere. This means that space-based telescopes can observe objects at much higher resolutions than those on the ground. The first dedicated space telescope was launched in 1990, and was known as the Hubble Space Telescope, HST. Since then, several other types of space telescope have been launched, including the Chandra X-ray Observatory, the Spitzer Space Telescope, and the James Webb Space Telescope, launched in 2022. These different types of observatory allow us to study different aspects of astrophysics. Whilst HST is optimized for visible light observations, Chandra observes high-energy X-rays emitted by hot gas surrounding stars and galaxies, and Spitzer studies infrared light emitted by colder objects such as planets and interstellar dust clouds. One advantage that all these space telescopes share is their location above Earth's atmosphere. The atmospheric turbulence present on Earth blurs astronomical images, making them appear fuzzy when seen through a ground-based telescope. However, this isn't an issue for those orbiting high above. Additionally, because there is no atmosphere present to absorb certain wavelengths of light, such as ultraviolet, space telescopes can detect these otherwise invisible emissions too. Hubble Space Telescope. The Hubble telescope was launched in 1990 and has been one of the most successful astronomical tools ever since. It has allowed us to see things that we never thought possible, like the birth and death of stars, galaxies colliding, and black holes devouring matter. For a long time, astronomers were limited to looking at objects in our own galaxy, the Milky Way. But with Hubble, we can now peer deep into space and get a glimpse of other galaxies billions of light years away. Not only that, but by studying these distant objects we can learn more about the history and evolution of our own galaxy. One of the most important discoveries made by Hubble is that there is an accelerating expansion of the universe. This means that not only is the universe getting bigger over time, but it's doing so at an ever-increasing rate. This discovery has completely changed our understanding of cosmology and has given rise to new theories about what might be causing this acceleration. There are currently 4 main telescopes in orbit around Earth: Chandra X-ray Observatory, Compton Gamma Ray Observatory, both operated by NASA, European Space Agency's Herschel Space Observatory, and Hubble Space Telescope. All 4 provide invaluable data for astronomers here on Earth. However, each type focuses on different types of electromagnetic radiation, providing complementary information about celestial bodies. In terms of longevity, both Chandra, launched in 1999, and Hubble, 1990, are expected to operate through 2030. Herschel completed its mission in 2013 after operating for just under 4 years, while Compton's deorbiting process began in 2001 upon the decision to shut down operations before eventually crashing into the ocean. Cost between their launchings also varies significantly, $50 million for Compton compared with almost $4 billion for Hubble. Interestingly enough, though often considered less advanced than newer models such as the James Webb, which reportedly cost around $8 billion, estimated price tags seem to have increased from initial projections to approximately $1 billion. Some argue the originality of the design makes it a timeless piece of machinery worth every penny expended. Spitzer Space Telescope. The Spitzer Space Telescope is one of the most powerful astronomical tools ever designed. It has allowed scientists to peer back in time to see the universe as it was billions of years ago and study planets around other stars. Spitzer was launched into space in 2003 and is now in its extended mission phase, which will continue until 2020. The telescope's infrared sensors allow it to detect objects that are too cold or too distant for visible light telescopes such as NASA's Hubble Space Telescope. During its primary mission, Spitzer made more than 35,000 observations of everything from nearby comets and asteroids to the most distant galaxies. These data have led to more than 1,700 scientific papers published in refereed journals. Spitzer also observed hundreds of exoplanets, or worlds beyond our own solar system, helping astronomers better understand these strange new worlds. And by peering at star formation regions within our own galaxy, Spitzer has given us a glimpse into how future generations of suns and planets might form and evolve over time. Herschel Space Observatory. The Herschel Space Observatory was a space telescope launched on May 14, 2009. Named after Sir William Herschel, the British astronomer who discovered infrared light, the observatory observed in the far infrared and submillimeter wavebands. These are wavelengths that are longer than those visible to the human eye but shorter than radio waves. The observatory was designed to study every phase of star formation, from molecular clouds where stars form to protoplanetary disks around young stars, from nearby cold stars like our Sun to distant galaxies billions of light-years away undergoing intense bursts of star formation. It also looked at how water and other molecules are heated throughout cosmic history by studying objects such as comets and planets within our own solar system. Herschel made over 35,000 scientific observations during its lifetime and surveyed more than 600 square degrees of sky, an area twice the size of the full moon. The mission ended on April 29, 2013 when Herschel ran out of liquid helium coolant needed to keep its instruments at very low temperatures so that they could make sensitive measurements. Chandra X-ray Observatory. The Chandra X-ray Observatory is also known as Chandra. It was launched on June 15, 2018 and has been operational since July 1. Chandra has the ability to take extremely high-resolution images of distant objects in space using its state-of-the-art pixel detectors. These images are then used to study the physics of these objects in greater detail. As an X-ray observatory, Chandra is uniquely suited to study some of the most energetic phenomena in our universe such as supernova remnants and black holes. By studying these objects we can better understand how they impact their surroundings and the overall evolution of galaxies. Additionally, because X-rays penetrate dense interstellar gas and dust clouds that block visible light, Chandra gives us a unique view of star formation regions within these clouds that would otherwise be hidden from view. Chandra was designed and built by Ball Aerospace and Technologies Corp. Under contract with NASA's Jet Propulsion Laboratory, JPL. The total cost for development and construction was approximately $600 million US, which includes 5 years' worth of science operations costs once it reaches its final orbit around Earth's Lagrange point 2, L2. L2 is a gravitationally stable location about 930,000 miles, 1.5 million kilometers, from Earth where spacecraft can maintain a constant position without needing fuel for station-keeping maneuvers, making it an ideal location for long-term observations like those planned for Chandra. James Webb Space Telescope. The James Webb Space Telescope, previously known as the Next Generation Space Telescope, is a space telescope that was launched in 2022. It is named after James E. Webb, the second administrator of NASA. The telescope has been described as the most powerful space telescope ever built and has a primary mirror measuring 6.5 meters, 21 feet, across, almost twice the size of Hubble's 2.4 meter, 7-foot, mirror, and 27 times its collecting area. Webb will observe objects ranging from exoplanets to extremely distant galaxies and enable scientists to study every phase in the history of our universe, including the formation of stars and planets. Thank you for listening. For more answers to questions on health, science, technology, business, culture and more, don't forget to subscribe to Know It All.